Hey everyone, this is Bradley Bush with another algebra video for you. If you're new to my channel, I'm excited you're here. If you're coming back, that's fantastic. Thanks for returning. If you enjoy what you see or if this is helpful, please subscribe to the channel and give me a like and leave a comment. Factorials are the topic of discussion today. Factorials are kind of fun. It's kind of an unusual thing we talk about in mathematics. First, we'll discuss what is a factorial. Then we'll talk about evaluating and simplifying factorials. And we'll discuss factorials in sequences and in summation. And we have a lot of examples for you. So let's get going. A factorial. What is actually a factorial? We denote a factorial with the exclamation point. It's kind of an unusual symbol to use in mathematics, but we do. We say it n factorial, or it's read n factorial. N factorial, n is a positive integer, and we can define n factorial like this. N factorial just means we take n, which is a positive integer, and we multiply it by every positive integer less than n down to 1. So for example, 5 factorial would be 5, which is n, times all the numbers below it, all the integers below it, down to 1. So 5 times 4 times 3 times 2 times 1, which would be 120. Not a difficult concept, but it's a little unique. And by definition, this is also important, 0 factorial equals 1 by definition. Let's look at some of the values of n factorial. 1 factorial would just be 1. 2 factorial would be 2 times 1. 3 factorial would be 3 times 2 times 1, 4 factorial, 4 times 3 times 2 times 1, and 5 factorial, 5 times 4 times 3 times 2 times 1. Something that's interesting here is that there's a lot of repetition, right? So in 5 factorial, we have 5 multiplied by 4, by 3, by 2, by 1. But if you look at it, there is nested inside of 5 factorial, 4 factorial. 4 times 3 times 2, and 3 factorial, right? And 2 factorial, for that matter. They're all there. So there's a lot of repetition, and which that leads to a lot of cancellation when you're simplifying, which is fantastic. Some of you who are cancellation addicts, this might be your favorite video ever. If I was to evaluate 6 factorial times 5 factorial divided by 4 factorial times 3 factorial, I could look at it and then write out what all of the numbers were to see what the repetition was. And I would see that there's actually a lot of common terms that can cancel. For example, 6 factorial, I've written out 6, 5, 4, 3, 2, 1. All of those multiply together. And then 4 factorial on the bottom, I have 4 times 3 times 2 times 1. And you notice that there is some common stuff. So in other words, 4 factorial in the bottom can completely cancel with the 4 times 3 times 2 times 1 that's in the top instead of 6 factorial. So those go away. And if I look at the 5 factorial in the top, I can see that the 3 factorial on the bottom can completely cancel out the 3 times 2 times 1 in the top. So those cancel. And I'm just left with 6 times 5 from the 6 factorial and the 5 times 4 from the 5 factorial left. That gives me 30 times 20, and that gives me 600. Not too shabby. Let's evaluate these ones. And I have the answers on the left side in gray, in case you want to stop the video now and do them on your own and see what you get, and then watch the video to see if you got the right answer. Well, you know if you got the right answer, but you can watch it to see how I did it, or you can see where you messed up if you didn't get the right answer. The first one will be 17 factorial over 15 factorial. So let's start writing out 17 factorial. We have 17 times 16 times 15 times 14. And we're going to keep going here because we've got a lot of stuff there, but just for the sake of space, I'm going to say ... for all the stuff in between, and I'll have times 2 times 1. And in the bottom, what do we have? We have 15 times 14 times all the way down to 2 times 1. We can see that we have some cancellation going on, which is going to be beautiful, right? The 15 times 14 times 13 all the way down to 2 and 1 in the top and the bottom can completely cancel. So we can just get rid of it. And what are we left with? We're just left with a 17 times a 16, which is 272. Let's try B. In B, we have 20 factorial, which it's a big number, right? 20 times 19 times 18 times 17, and we keep going. I'm not going to write them all, right? Because that would take too long. But it goes down to 2 times 1. And then we have 2 factorial, 2 times 1. I'm going to put a parenthesis around that. And then I have the 18 here, 18 factorial, 18 times 17 times 16 times 15. My handwriting is terrible today. Seriously. ... times 2 times 1. It might be that I'm freezing right now and I can't write. I can't write very well. Excuses, right? We can see that the 18 factorial on the bottom can cancel with 18 times 17 times 16 all the way down to 2 and 1 at the top. That's really great for us, right? A lot of cancellation going on. So what we're left with, oh, look at that. The 20 can be 10, say, and the 2 just becomes a 1. So everything in the bottom just canceled out. And at the top, we just have 10 times 19, which is 190. Fantastic. Let's do example C. We have n plus 2. That's kind of weird. What do we do with that? Well, we treat it just like we did all of the rest of them. So we would take n plus 2. That's the term that they're currently. And then, just like before, we subtract 1. So we have n plus 2. And then we have a minus 1. And we have n plus 2 minus 2. And then we have n plus 2 minus 3. And we keep going, right? This is how the factorial works. All the way down to 2, and then 1, and then we're done with that. We have a nice line for division there. What do we have in the bottom? We have n factorial. So we have n times n minus 1 times n minus 2 times n minus 3, and so on, down to 2, down to 1, and we're done. So it might be a little hard to see now what cancels, but if we do some simplification, look at what we have. It's kind of cool. N plus 2 minus 1, that's really just n plus 1. So we have n plus 2, and we have n plus 1. Here we just have n, because the 2's cancel completely. And here we have n minus 1, because the negative 3 and the 2 become minus 1. And then we keep going down. The next one would be n minus 2, and then n minus 3, and so on, all the way down to 2 and 1. So notice something here. that's n factorial right there. N times n minus 1 times n minus 2, all the way down to 2 and 1. N factorial in the top and the bottom. Those totally cancel. So let's get rid of them. What do we have left? Well, we have an n plus 1 and an n plus 2. N plus 2 first, and then we have the n plus 1 left. Very cool. This last one. 2n plus 1 factorial divided by 2n factorial. So again, we are going to start with 2n plus 1 because that is the term that's there to begin with. And then after that, we're going to subtract 1, right? So, whoops. 2n plus 1 minus 1 2n plus 1 minus 2. Somehow I switched to black. Let's switch back to blue. And then we have 2n plus 1 minus 3. And so on down to 2 and 1. Because we don't know what 2n plus 1 is. Because we don't know what n is. So we don't know what 2n plus 1 is. But it's some integer. It's some positive integer. And if we keep subtracting 1, we're going to eventually get down to 2, 3, 2, and 1. So we can just write that. The same thing with 2n. We don't know what 2n is, but whatever it is, if we keep subtracting 1, we'll eventually get down to 3, 2, 1. So we keep doing that here. 2n minus 1, 2n minus 2, and then 2n minus 3, and we keep going all the way down to a 3, a 2, and a 1. So again, it's a little, we're not quite sure how this is going to work out, but if we simplify things a little, we're going to see that things look great. So the 2n plus 1 stays there. The 2n plus 1 minus 1, the plus 1 minus 1 cancel. We just get 2n. Well, that's interesting because that's what we have down below. How about the 2n plus 1 minus 2? That gives us 2n minus 1. That's interesting. That's the next term. 2n plus 1 minus 3, that gives me 2n minus 2. This is looking fantastic. And all the way down to 2 times 1. That's exactly what we have below. So we can see that everything in the bottom cancels with almost everything in the top. And we're left with just the first term. 2n plus 1. Very cool. Finding terms in a sequence involving factorials. So for example, find the first 4 terms of the sequence a sub n. And here's the general form of the sequence. Here, a sub n equals, in the numerator is a fraction. In the numerator, n plus 1 quantity factorial. And in the denominator, n squared. Again, I've put the answers on the left in gray. So if you want to stop right now and work them out by hand and then see if you got it right, and then continue on, you're welcome to. So when n equals 1, again, all I'm doing is copy and pasting this general term down 4 times. And then what I do is I just replace the n everywhere with what n equals. at that specific time. So our first time n equals 1. So I replace the n with 1. 1 plus 1 factorial, that's just 2 factorial. And in the bottom I have 1 squared, which is 1. So 2 factorial just gives me 2 times 1, which is just 2. Next one, I have 2 for n equals 2. So I've got 2 plus 1 on the top, which is 3 factorial. And that is all divided by 2 squared, which is 4. 3 factorial is 3 times 2 times 1. And then we have 4 in the bottom. This gives us 6 over 4, which is 3 halves. Let's see what else we have here. N equals 3. We have 3 for n. So again, this is just the same general term. I just put in 3 for n. So 3 plus 1 gives us 4 factorial over 9. 4 factorial equals, oh, it's not a very good equal sign. 4 times 3 times 2 times 1 over 9. We can simplify a little bit here. This 9 is really 3 times 3. And that one of the 3's can cancel with one of the 3's in the 9. So that leaves us with 8 over 3. And the fourth term, again, everything stays the same. We just change n to 4. So we've got 4 plus 1, which is 5 factorial. All over 4 squared, which is 16. 5 factorial is 5 times 4 times 3 times 2 times 1, all over 16. Well, 16 can be written 4 times 4. And one of the 4's in the 5 factorial, the 4 in the 5 factorial can cancel with one of the 4's in 16. And then the 2 in 5 factorial can cancel with one of the 2's in the 4 and leave us just with 2. So we're left with just 2 in the bottom, and we have 5 and 3 in the 1, which give us 15 over 2. Awesome, let's move on. Let's talk about factorials and summation, because factorials often appear in summations. Here's an example. Find the indicated sum. And we're summing, there's a fraction, and it's in the numerator. We have -1 raised to the I plus 1. So I plus 1 is in the power. And then the denominator, we have quantity I plus 1 factorial. And we're summing this from I equals 0 to 4. So we're going to have 5 terms. I equals 0, I equals 1, 2, 3, and 4. And first, all I'm going to do is replace the I with whatever it is in these 5 instances. So when I equals 0, I've got to replace the I with 0. So I have 0 here plus 1 and 0 plus 1 factorial on the bottom. 0 plus 1 in the numerator, or in the power, just gives me 1. -1 to the first power is just -1. And 1 factorial in the denominator is just 1. So I have -1 in my first term. Second term, I equals now 1. it was 0 before, and now I equals 1. So I'm going to change my I to be 1 this time. So I have 1 plus 1 in the power, that's 2. Negative 1 to the second power is positive 1. So I've got a positive 1 in the numerator. And in the denominator, I have 1 plus 1, which is 2 factorial, which just gives me 2 times 1, or just 2. Now when I equals 2, I can replace the I again with 2. So I have a 2 in both of those places. So I have negative 1 to the 2 plus 1. That's negative 1 to the third power. That's an odd power, so I have negative 1 there. And 2 plus 1 is 3. 3 factorial is 3 times 2 times 1, or 1/6, negative 1/6. So we end up having a negative 1/6 here when I equals 2. How about when I equals 3? Well, I need to get rid of the I there and put 3. So I have negative 1 to the fourth power, which is just 1. And then I have 3 plus 1, or 4 factorial, which is 24. So I end up having 1 over 24 for this term. How about when I equals 4? Again, I'm just going to replace the I with 4 and keep plugging along. So I have negative 1 to the fifth power, which is a negative 1 because we're raising it to an odd power. And then I have 5 factorial in the bottom, which is 5 times 4 times 3 times 2 times 1, or 120. So I get negative 120 here. If I combine the terms in the second row, I look at them and I think, let's do a little bit of simplification. Let's start with my negative 1 and my 1/2. That gives me negative 1/2. Negative 1 plus 1/2 gives me negative 1/2. And I still have my negative 1/6, my positive 1 over 24, and my negative 1 over 120. I need to get a common denominator, so I probably should do some multiplication here and get a common denominator. So I should multiply by 60 over 60 with the 1/2. And the negative 1/6, that needs to be a 120 in the bottom. So I should multiply by 20 over 20. The 1 over 24, I can multiply by 5 over 5 to make that 24 or 120. And the negative 1 over 20 is already has a 20 in the denominator, so we're good. That leaves me with negative 60 over 20, negative 20 over 20, 5 over 20, and negative 1 over 20. They all have the same denominator now, and I can just add the numerators. So negative 60 and negative 20 gives me negative 80, and then I have one more, negative 81, and then I add 5 to get negative 76. So I have negative 76 over 120, which can simplify. There's both of those numbers are even, so I can pull out at least a 2, and actually I can pull out a 4. So if I pull out a 4 and cancel the 4s out, I'm left with negative 19 over 30. So my sum of negative I to the I plus 1 over I plus 1 factorial from 0 to 4 is actually just negative 19 over 30. Let's do one more. Find the indicated sum. We're summing quantity I plus 2 factorial divided by I factorial. And we're summing from I equals 1 to 5. So again, I need to just copy and paste. And I'm going to copy and paste the quantity I plus 2 factorial divided by I factorial. I'm going to do it 5 times for I equals 1, 2, 3, 4, and 5. And then I just need to change the I to be whatever it is for the situation, and then simplify. Let's start with the I equals 1. When I equals 1, what does our quantity equal? Our quantity is going to be, there's a 1 here and a 1 there. We end up getting 3 factorial over 1 factorial. 3 factorial is just 3 times 2 times 1 over 1 factorial. That just gives us 6. So we end up having 6. When I equals 2, what happens? Well, let's see. Let's plug in 2 and find out. 2 plus 2 gives us 4 factorial. And we have 2 factorial on the bottom. There's a little bit of canceling going on here. The 2's can cancel on the top and the bottom. We get 4 times 3, which is 12. What about when I equals 3? Again, let's get rid of the I and put in 3. So we get 5 factorial on the top and 3 factorial on the bottom. You can see that there's some cancellation on the top and the bottom. We're just left with 5 times 4, which is 20. All right, how about when I equals 4? Well, that gives us 4 plus 2, which is 6 factorial. And I have 4 factorial on the bottom. Notice there's some cancellation. The 4 factorial on the bottom can cancel with the 4 factorial inside of the 6 factorial. And we're just left with this 6 times 5, which is 30. You're kind of seeing a pattern, I bet. So when I equals 5, let's see if I can get that dot. There I go. When I equals 5, what am I left with? I have 7 factorial on the top and 5 factorial on the bottom. So the 5 factorial on the bottom cancels with the 5, 4, 3, 2, 1 in the top, and I'm left with 7 times 6, which is 42. Now I can add the 6, the 12, the 20, the 30, and the 42, and I get 110. So my sum of quantity I plus 2 factorial divided by I factorial, when I sum from 1, I equals 1 to 5, is 110. All right, that's it. Hope you enjoyed it, and have a good day.